that we know the acceptable interval notations and set builder notations for our final answers, the question then is, how do we actually solve inequalities? So as you look at the handout, you're going to see that I've given you an equation. X minus 3 is equal to 7. In order to solve that equation for x, to get the x alone, you would add 3 to the left-hand side and the right-hand side. So the first comment is that a lot of the things that we did in equation world are going to be the same as the things that we do in inequality world. So if you add a 3 to the left, you had to add a 3 to the right in equation world. That statement is going to be true in inequality world as well. But the other question is everything else going to be exactly the same? And the answer is yes, to a point. So let's figure out then what things we can do and then what things we need to change up a little bit in this world of inequalities. So in order to understand this idea, I'm going to start off with the inequality 2 is less than 4. And my question is, what can I do with this inequality? So I'm going to start off by saying, can we do the same kind of thing we just talked about in the world of equations? Can I add 3 to the left-hand side and to the right-hand side of this inequality and still have a valid inequality? So let's try it. So let's add 3 to the left-hand side and then add 3 to the right-hand side. 2 plus 3 is 5. 4 plus 3 is 7. So my question then is 5 less than 7? And the answer is yes. And because the answer is yes, that means then that adding 3 to both sides of an inequality will still create a valid inequality. Well, what other things can we do? So you'll notice in my table, I've come in and said, well, okay, let's try something else. So once again, notice I have the 2 is less than 4 as my base inequality, but this time I'm saying, can I subtract 1 from both sides? Well, let's just check it out. 2 minus 1 is 1, 4 minus 1 is going to be 3. Is 1 less than 3? Yes. So as you look at these two pieces then, notice something that we can say as a generalization. We can add or subtract the same number from both sides of an inequality and we will still have a valid inequality. Well, what about multiplication and division? Let's start by multiplying and dividing both sides by a positive number. So once again, starting with 2 is less than 4, let's multiply both sides by 3. 2 times 3 is 6, 4 times 3 is 12, 6 is less than 12. So multiplying both sides by a positive number is a perfectly acceptable operation. How about division? 2 divided by 2 is going to be 1, 4 divided by 2 is 2, 1 is less than 2. So yes, that's fine as well. So again, let's go ahead and take those two and generalize. We can multiply or divide both sides of an inequality by a positive number, and once again, we're going to end up with a valid inequality. Now, at this point, you might be thinking, oh, everything's working. Well, we have to be kind of careful, though. So let's try our last row. Is 2 times negative 1 less than 4 times negative 1? If I multiply both sides by a negative number, are we still going to be valid? Well, let's try it. 2 times negative 1 is going to be negative 2. 4 times negative 1 is going to be negative 4. So the question here is negative 2 less than negative 4? Well, the answer on that one is no. And you might need to go off to the side. You'll notice I've given you a number line. We can put the negative 2 on here. We can put the negative 4 on here. Negative 2 less than negative 4 would mean that negative 2 has to be to the left of negative 4. Negative 2 is not to the left of negative 4, so that's why my answer is no. So what this is telling me is that if I multiply both sides of an inequality by a negative number, and that's it, I won't have a valid inequality anymore. Well, okay, let's see if division is any better. So 2 divided by negative 2 is negative 1, 4 divided by negative 2 is negative 2, and the question here is negative 1 less than negative 2? The answer once again is no. So I can't come in and divide both sides of an inequality by a negative number and stop there and expect it to be a valid inequality. So what would happen if I really wanted to do that? What if I really wanted to multiply both sides by a negative number? So could I change this problem up a bit and make a valid inequality? So you'll notice that we can come in and say, oh, let's just change that inequality symbol. If I have negative 2 and negative 4, I can't have a less than symbol to make a valid statement, but I can switch that up. And instead of having a less than, I can flip the inequality symbol and I could put a greater than. So negative 2 is greater than negative 4. Well, how about his friend over on the division world? Once again, negative 1 is not less than negative 2. So what symbol could I put between those two? Negative 1 here, and then the negative 2 on the other side. I could put a greater than symbol between those, and I have a valid statement. So I started with a less than, and in order to make a valid inequality statement, I had to have a greater than. Same thing here. I started with a less than. In order to make a valid inequality statement, I had to change that into a greater than. So under the table, I've given you a fill in the blank. When you multiply or divide both sides of an inequality by a negative number, you must flip the inequality symbol. So what that means then is if you started with a less than and then multiplied by a negative, you would have to flip the less than symbol into a greater than. Or if you started with a greater than, you need to flip the greater into a less than. Now, in order to prepare you for the worksheet for today, I'm just going to go ahead and write off to the side a different wording for flip. Another word that I could use, or another phrase that I could use, is say change the direction of. So anytime you multiply or divide both sides of an inequality by a negative number, you need to change the direction of the inequality symbol.